General Protocol Spaces. Banking on Freedom.
Yo, let's get it started. Okay.
Yo.
General Bull 13 of N. Didn't think we'd get to 13, but here we are. And we have a very cool guy with us today, Calin Kulianu. As I said on the Twitter, the original tweet for this place, I said, do you know what all software this guy has made? And I started writing down a list and I was like, wait, I don't even know all the stuff Calin has made. But even the list I had is already a long, interesting list. So hopefully we can get into some of that, talk about the stuff that Calin has worked on in Bitcoin Cash and elsewhere. And then there's just, I don't know, a lot of insights I think that Calin has. So welcome, Calin. Thanks for joining us.
Oh, thank you for having me. Well, that's quite an introduction there. I appreciate the kind words.
No, you deserve it, man. Like
the praise.
I was talking with Uname about what name should we use for it. I was like, King of Infrastructure. I was like, infrastructure. It's like coming up with all the names for it. But yeah, Baconized infrastructure is what we landed on at the end. So
yeah, I like that term.
Let me make the list here of the ones that I know or that I heard about quickly when I was asking Uname. So of course there's Fulcrum, which maybe we can explain what that is later, but there's Fulcrum, which you're the creator of or co-creator of, and maintainer.
I mean, yeah, you can say co-creator because the protocol itself was designed by other people. I just wrote it from scratch in C++. So a lot of
I remember when you started that, and I was like, that's silly. That's kind of dumb. And then you were done with it, and I was like, I was wrong. It was amazing.
Yeah, I mean, I was just like, I wonder how fast this could be in C++ because the thing was written in Python. I'm like, this is insane. Why Python for a server? Why? It's like, I wonder how fast it could be in C++. And I did it as an experiment initially. And it was like so much faster. I was like, oh, I gotta keep making this a final product because it's just so much faster.
Yeah, I remember at the time it was released, I was running at least one instance of Electromax, and then the emergent reasons, and I think some other people were like, oh no, another implementation, isn't there something better we can do?
Yeah, I was complaining about it.
And then Reddit was like, dude, this thing is good. Holy shit.
Yeah, especially with the higher demand stuff that has appeared in recent times, right? Like the Cache Fusion and like our own apps that are doing things at pretty high speed. So yeah, you gotta have something that works.
Yeah.
So
it's fast and it's compact. It's not like, the whatever 2 terabyte shit that Blockstream is running.
Right. Yeah. Okay. So we haven't even.
They had Explorer or whatever. Explorer it's called. Yeah.
Explorer. Yeah. Okay. So there's Fulcrum. I can explain what that is later. You can. And then there's BCHN, which you are one of the co-founders and key maintainers of. So that's a big deal. That's a Bitcoin Cash node. There's Electron, which Uname and I were discussing whether you were the co-forker of that or not, or did you?
No, I wasn't, but I came in pretty early.
Forked.
It was Jonald and Cupichan, Neil Booth.
Right.
Yeah, they were the key forkers, and I came in maybe 6 months into it because they needed help with stuff, and I don't know what I was doing. I didn't know Python at all, really. I hardly use Python. So my old Python code is terrible, but then I got better. I figured out what the language is about, and I got better.
Oh man, that's like the hardest starting point I can imagine is the Electrum code base for Python.
Yeah, because a lot of it is messy, so it's not like you learn best practices.
Such a mess.
But sometimes it's good because there's room for personality, and when there is no one standard personality of the code, you can just do whatever, and you can sort of find your own way. I mean, that's the good part about it. It's like a wild west of a code base.
It really is. It's wow. I thought I was going to contribute one day and I popped it open and I just was like, nope, I closed it back. Okay. So there's Electron, the wallet, Electron. And then there's, CK Pool, the pool mining pool software.
Now known as A6 Year Pool.
A6 Year Pool. Right.
Yeah. Although I think ASICs here themselves are now out of business, so maybe we should rename it. But yeah,
Okay.
it's basically just maintaining a Bitcoin fork of a like not decentralized, but of a non-custodial pool where you get paid out.
Non-custodial pool, which is
a
very relevant deal these days.
We should just be totally uncreative and call it like CK Pool Cash or something.
Yeah, we probably should rename it back. Initially, like ASICs here funded the development. They're like, yeah, just fork it and I'll pay you. And I was like, all right. And they gave me like $5,000 or whatever, to maintain it, one-time payment. But the thing is that code base is kind of buggy. Like I don't trust it. It probably needs to be like fixed. But yeah, that's a side conversation.
Well, it seems I don't know. Like it seems a bit better. It seems better than CK Pool itself. So.
All right.
Yeah,
all right.
But still has. There's a bugs. Like it's still got bugs in it. I think because I've seen it crash just randomly for no reason.
It's still got bugs, as if any software. All right. So there's CK Pool. Then there's a CPU miner, which you name reminded me of, which you re-upped, kinda, right?
I don't know how the original how the original performs because I could never compile it. So.
Oh yeah, what else? I just added a couple of features to it. It's really just a fork of the. Yeah, it's not. But yeah, that's true.
CPU and that's miner, useful for like testnet type stuff, right? The CPU miner is useful.
Yeah. When you just want to mine, testnet or even reg test if you want to do something locally. Although with reg test, you can just send a command.
Right. Generate block, right. Or for your any dead chains that are out there and somebody's wanting to keep it alive, you can just keep mining that chain.
Yeah.
So there's the CPU miner. What else have we missed in the kind of first off in the Bitcoin space that's not on the list here?
I can't remember. That's probably the big.
Those are the big ones.
Most important stuff.
All right. And then, do you want to talk about the things you've done outside of that? I believe you have a background in HPC, right?
Kind of. I don't know what you would call it. I initially worked like in control systems, like but not industrial control, like for scientific experimentation.
Right.
Where you have you're like running some device that runs an experiment in the biology, like in a lab. You have like sensors and you want to actuate some motors, and they were doing stuff with animals, like animal experiments, and they needed like fast code to like measure stuff really quickly. And that's where I was working for many years. I worked for Cold Spring Harbor Labs, and I worked for the Howard Hughes Medical Institute in Virginia.
And then was some of that HPC? Sorry, when I mean HPC, I mean high-speed computing. High performance computing setups. That's like these.
Right. So HPC typically would mean like running like huge simulations or something, or
right.
It wasn't that exactly. It was more like you needed to do real time stuff. Like you're getting
real-time
like
stuff.
A few megabytes worth of data a minute or a second, and you want to like quickly analyze it. I mean, it is high performance, but not when you typically say HPC, people think of like running like numerical simulations.
Yeah, no, real time code is a whole another intersecting world there. So I see. So you were working on real time stuff. Then it makes sense why you would fit with that with C++. Okay. So you've written a lot of software, a lot of different things. Go ahead. Yeah. Sorry.
Yeah. So like that made me very sensitive to performance. Like you learn a lot of performance tricks working and stuff like that. Not that I'm the most like obviously performant programmer, but it made me like sensitive to that, which is why like I wouldn't want to write a server in Python. Like that was insane to me.
All right. Yeah. So I thought maybe we could, or you and Uname could go through some of those things you've worked on and just give us some insights on what you've learned. So I'll leave some of that to Uname. At later, I'd like to also ask some questions about your thoughts on various code bases, especially the Satoshi code base, the original Bitcoin code base, because whenever I hear random people talk about it, there's always a conflict between like how people talk about it and then what I've heard you talk about it. And then when I compare the credentials of random dude and Calin, I'm like, I should probably lean towards Calin's analysis of the code, right? Like that's your wheelhouse. And there's always a conflict between those. You know, people are always like, oh, it's low quality crap. He was not a programmer. And then I heard you talk.
Is that what people? What are some of the things that? Yeah, what are some of the people that what are some of the things that you've heard people say about it? I'm curious.
Yeah,
because I've
okay. Let's maybe go ahead and do that first. I think it's pretty universal. Like almost anywhere I've heard people talk about it, and I think there has a whiff of like truism where people have just accepted it as the truth. But I always hear this. You know, you talk about the original Bitcoin code base, and people say, "Oh, its quality is low. Satoshi was not a real programmer. He was just, you know, something. Maybe he was an academic, something, and the quality is low. It was full of bugs and that kind of thing." But yeah, I've heard you say something very different from BTC people. To that. Let's see.
Yeah, I mean, I've worked with academic programmers.
Did you hear the same kind of things about Bitcoin code base, the original Satoshi code base, or what have you heard about it?
Oh yeah. It's basically as what you said, and I mean I don't doubt that there's a lot of improvements that are made by the community over the years. There has to be, you know, like there's only so much one person can do. But yeah, there's a lot of there's a lot of very I would say very pronounced criticism about him, even as one single person. So,
right. Jonathan, have you heard anything? Oh wait, Jonathan's not on. Are we gonna have another thing where?
No, I'm here, and yes,
okay. On mine it says you're a listener.
Yeah, that's
Twitter
Twitter for you.
The mess.
Yeah, so I've also heard most of these talking points, and I know there was a poker client inside of it, so that's scope creep in my world. I know that large swaths of the instructions in the VM language has later been disabled because there was not proper like overflow control on some of the functions. And generally, some parts of the system were given more attention than others while developing it. So yeah, my expectation, and I haven't read that code base, but my expectation for that code base is that back in the days, it wasn't very high quality. It's yeah, I kind of agree with the assessment that people have talked based on what I've heard so far.
Yeah, so that's what we've heard, Calin. So what was your insight for somebody who actually works with it on a daily basis? And has looked back through the history and so forth. What do you see when you look at it?
I see a single guy who's extremely competent and he's experienced, and he solved a lot of problems at once. You know, you can't do everything just by yourself.
So you say a single guy. Is that a key point? Is that
it feels like a single guy? To me, it feels like a single personality. Just like it's idiosyncratic in a particular way. And you know, like the way people used to do C++ and programming in general, like in the 90s, you know, before the internet, before Git, before, you know, you'd have each shop have its own culture in a code base. So like, you know, if we look at it through the prism of like modern times where like we've come to like standardize the way people do code, I don't think that's fair. I don't know. Like I really think he was a really smart guy. Like he knew his stuff, man. Like he wrote a whole application from the ground up that did something groundbreaking, and it works. And most of the stuff inside of it is idiomatic and it's well thought out, and it's like use, you know, industry standard techniques, you know, for stuff. You know, like this, even the block file stuff where you reserve space on the disk, you check for disk space, like that kind of, you know, those are just tricks that like a Windows programmer would use, you know, or whatever. Like, you know, I don't know, like, you know, it's easy to sit back now and like judge him, you know, like be like, hey, he didn't, he put a poker client in it, you know, what is that? But I think he was trying to get like a killer app in it quickly. And that is scope creep, you know, that's true. Yeah, but
I can appreciate the thought of
people use it for.
I can appreciate the thought of, okay, I'm going to make this amazing software and then nobody's going to actually do anything with it because and I think that kind of reveals, scope creep, but it also reveals practical knowledge of you can make the most amazing thing in the world, and if you don't make it somehow useful or whatever to people, it'll just sit there and nothing will ever happen. You know, build it and they will come is not.
Yeah, I think he was thinking, oh, you know, maybe if I have a fun game in there or something, you know, people will use it, and that's how we'll start. People will just. I mean, I think that's what he was thinking. I don't know.
yeah, it's impossible to know, but I totally agree with you about idiosyncratic code. Like you can look at code, and unless somebody's just like perfectly following some rule set, which was much less rare back in the day, right? You can look at it and be like, oh, I know who wrote this.
Yeah,
you know, it's like handwriting. You can look at it and you know, I know whose code this is. I know who writes like this. So you think it's pretty idiosyncratic, like it had a flavor to it that you can identify.
Oh yeah, yeah. I mean it, and especially like you said, especially with programmers that come from the 90s or the early 2000s, that's even more so because there wasn't as much sharing of information and culture.
Oh,
like
yeah.
you know, coding has a culture to it.
Absolutely.
So you get like more, you know, like some guy coming from finance has his own idiosyncrasies. Some guy coming from games, you know, gaming. Some guy coming from, you know, whatever is it's gonna have a different, like just the way even they organize their code, the way they name things, the way, like all of it. And so yeah, with Satoshi, it feels like one guy with one particular flavor to the way he does things.
Very interesting. And you were saying about, I mean, one of the impressive things about it is it just covers so many things, and then each one of them was reasonably novel, right? Like nothing is novel completely, right? But all these different parts of it that he was putting together, each one of them was not like an off-the-shelf thing, or was it? Or was this actually a lot of novel things that he put together in a novel way as well? Not from an idea perspective, but from an actual, you know, implemented code perspective. Was a lot of it off-the-shelf stuff, or was it stuff that he had to, like, from scratch, build all of it up?
It felt like he'd used just industry trade secrets that he'd seen before, like for certain things, like the way he kept track of time, the way he thought about time, like with the blocks, and like sort of like the, you know, the whole thing about like the network average time or something, where you average the time of your peers, and you sort of you take that to mean that's your, you know, that was like the way to do things back, you know, before NTP was really common.
Yeah, that's right. And
I don't know, like,
wasn't a thing.
It felt like there were a lot of just like trade secrets in there that he'd seen in other places that he, you know, integrated in his mind, and he put it into one application. Like it, yeah.
Okay, so it felt like he had drawn from very. It didn't look like it was a noob coming up with stuff and made a lot of noob mistakes. You're saying like that there was quite a bit of robustness in it already from the start.
Yeah, it felt like a guy who'd written a lot of applications before. Like, yeah.
Okay, yeah. See, like that's something I usually don't hear. Right? It sounds like no, he was just somebody who was slapping stuff together and didn't really have experience. But you're saying it to you, it looks like they already had a bunch of experience making apps. Huh.
Oh yeah, absolutely. That's beyond it. You know, I think there's a temptation to want to also diminish Satoshi in certain circles, like especially in the BTC world, right? Because like what they're doing now completely contradicts like the whole vision, right?
Yeah, it doesn't make any sense. Yeah,
you're gonna get like that temptation to want to like reduce his significance. I mean, he was just a man, you know. He's like one person, like, you know, one person. No one's a god. He was not a god.
Yeah, and working in isolation too. It's not like, I mean, maybe somebody knew who he was and he was getting help from somebody, but to a large degree, because of the whole setup that he made for himself, he couldn't really go out and be like, hey, I need help with this, right? He had to do that through very slow forums. It's not like today where it's so much easier to collaborate on things. None of the tools were there back in the day, right? So yeah, he was significantly working in isolation. That shit's hard.
Yeah. They didn't even have like, you know, what we have like GitHub and GitLab. Issue tracker is like, yeah.
Yeah, no, that was. I mean, not
the guy had SourceForge,
too far after Git. Git wasn't even. That
was it SourceForge? Yeah, SourceForge. Which is like SVM based, I think.
Oh, what did he use? Which
SourceForge.
SourceForge. Oh god.
Which I think Subversion, which was somewhat better than CBS,
Subversion.
which is still terrible.
He's using Subversion. Okay. Yeah. Oh my god, I'm so glad I don't have to use that anymore. I used to use that. Okay. What about anything else that you noticed with it? Yeah, I just remember hearing this and hearing the difference between these. Is there anything else that you think would be, contradict or go along with people's popular view of it? Anything else you noticed?
I mean, yeah. Should I talk specifics or?
Yeah.
I mean, my overall impression was that he was a really smart guy. I mean, he got the peer-to-peer stuff mostly right. Like the protocol works and it was pretty good. It may have had some flaws, but though he did scripting right, he did it as like forth basically, which is the right way to do it. You don't want to turn complete language, and forth is great. So he did a forth like language. He could have just had something stupid, like just have addresses that are just, mapped to just public key. It could have been without script at all. But he was like, oh, we need script because we want it to be a little bit more extensible. I don't want to decide exactly how people are going to use this money or how they're going to lock their money. And just even that insight, like the fact
that is a huge insight.
Bitcoin script was there.
Yeah,
like that was there from the first day, man. Like, he had so many problems to solve in parallel, and even the one sub problem was like, how do I define, where I send money to, and like locking the funds and then unlocking them. No, let's use a scripting let's use like a forth like language and non-turn complete. But even that, like just that one thing,
that alone
like,
seems that seems very unintuitive to me. Like that would not be the solution that most people land on. As opposed to just saying, oh, I send it and I lock it and I sign a key and unlock it. But to actually turn that into a process that's a scripting language, that's part of a scripting language is that's a surprising one to me, that even I am like, wow, okay, that was an interesting insight.
Yeah, I mean, he could have just been like, oh, initially I just want it working. Like the much larger problems are like the blockchain itself, like the Merkle root, the Merkle tree, the transaction format, like all these other things he's working on, and then like, oh, let me. He could have just focused. Like he could have just said, oh, for now we'll just have it. You send it to a public key, and that's it. Which he did end up using in practice mostly, but they send it to a public key, and that's it. And then we'll worry about later if we want to extend it. But no, he put a scripting language in there, like from the beginning. That's pretty good.
Yeah, absolutely. What about any parts that did look noobish to you, and you're like, that is pretty newbie?
It's hard to judge because when you first write an application, you're gonna do the easiest things, right? Like, I can't bring myself to judge it in that way. Like, it's just, it has its own historical context. It was C++ of the early 2000s.
Oh yeah, I don't mean as a judgment. I mean as, you saw sophistication in some ways, like the timing system that he used, which was already established, and using a forth-like language for scripting and so forth. These are ones where you're like, oh, that's a pretty sophisticated decision. Were there any decisions where you were like, he didn't know the state of the art, or he didn't know, not as a judgment, but as just like a knowledge thing, like he didn't have that experience, or he hadn't heard that before or seen it? Or was it pretty broadly, he implemented what made sense in each part of it?
Yeah, so I actually got ask.
Yeah.
What about the security aspects? Like he did include pay to IP number early on, right? And that paired with the have more than one application in there, like with that poker client, like increases attack surface. Personally, it like makes me wonder, like, what about the security aspect?
Yeah, that's a good point. Probably the security was the weakest of all the things, right? And also like people in the 2000s and 90s just didn't think in terms of security. Like that's evolved because that came with the internet, that whole where you can get attacked. You're connected 24/7 electrically to the whole world, and people can start attacking you. They send the right combination of bits to your network interface, and who knows what can happen. That's that's a paradigm shift, and that's an evolution that programmers had to go through. Like initially, nobody thought about that stuff, and I think he's coming from that school. So of course he made some mistakes. It just was a different way of thinking about this stuff. Yeah.
All right.
Okay. Yeah, the security might have been the weakest of all the things, maybe.
If you think of any more, feel free to share those while we're talking. But yeah, I think that's good to share and have out there where people can listen to it, because it's a counterpoint to the absolutely common perspective that I always hear, where people are just like, no, he was a noob. So that's great to hear. Thank you. So I was gonna.
Yeah, no, man. He was really smart, dude. No, he's not a noob. I don't know why people say that.
Right? Yeah. So I wasn't able to judge, but then when I heard you say it, I was like, okay, well, I know who I'm gonna trust. Common knowledge, or the guy who's actually looked at it and knows in depth how it works and has seen it. Back to the
and when you're one guy, you're going to be myopic. Like you're going to see some things really well and do them really well, and then other things you just don't pay attention to because that's like every person.
Or you only had like a year or two to make it, and fuck, you only have so much time to do, and you have you aren't able to spend as much time on every part of it as. So yeah, maybe there's going to be some parts that aren't as well developed. And then later, right? It's so easy to come at software later and be like, oh, well, this was so obvious. Once this happens, once you have 10,000 peers, well, it's obvious that this is going to happen. And it's like, holy shit, he wasn't sure if he was going to get 10 peers when he made this, right? So you have to start.
Yeah, exactly. He was the forum posts. Yeah, like the emails, like he's arguing with these guys. They're like, your system's going to suck. We're hardly going to use it. And then he released it and everyone started using it. So
you didn't know. You had no idea if it was going to be 1 or 10 or 10 million. So yeah, and you can't totally predict what your software is going to behave like or how all the things are going to emerge. Like what's going to emerge from things scaling up.
Yeah, the long-term thinking is probably the thing that impresses me most about all this. Like the fact that he said at some point, like, we'll either have a ton of usage or we'll have none. Yet, despite knowing that none is an option, he spent whatever time was needed to build out a system that wasn't really like the core features of it, like the distribution of the coins and the difficulty adjustment algorithm. Many of these things, they're thinking like, how is it going to look decades from here and have answers that will actually be satisfying decades from the start, instead of making something that like it's going to work for a month or two, and if it gets popular, we'll figure it out then, which is a very common thing I see elsewhere. So yeah, I the long-term thinking part, that one actually does impress me.
Yeah, I would agree. Even down to the way he thought about scaling with this, this SPV. He thought about SPV like in the white paper. Like that's pretty impressive. That's very long-term thinking.
SPV pruning, the pruning stuff as well, which still nobody's really fully implemented as we've been discussing recently.
Right, because he was thinking more like transaction level pruning, I think, where you keep so you can do SPV proofs. Yeah, no one's ever done that. No one's fully implemented.
Yeah. Okay. So speaking of how things have emerged since then, the first software that I brought up was Fulcrum. Could you explain shortly what Fulcrum is and why it's important, and why did you make this thing? Why did you decide that was important to work on?
Well, so unlike, I just wanted to dovetail it with the previous thing. Unlike Satoshi, I had the luxury of other people solving all the difficult problems with that protocol, and then I could just come in and be like, "Hey, you guys messed up here," and I re-implemented. So there's the Electron Cache client and the Electrum client, and all these they speak a certain protocol, and they expect the server to do indexing for them, to do address indexing and serve them in address history. And so the guys that designed that are the Electrum people in collaboration with Neil Booth, who was an Electrum person, who then forked over to Bitcoin Cash. So he and the Electrum guys designed the server, but they wrote it in Python because they figured, the server should be in the same language as the client. And that's good because then you can verify what the server's doing. Everyone understands some Python. So you can, there's a good reason why they wrote it in Python, I think. Because it's easier to audit. Like just with C++, it's like fewer people can just like pick up.
It's just so easy to get started with Python, and then it just goes from there.
Yeah, so that was the thinking, because the philosophy behind that is good. It's like, you should be able to audit the code. We should be able to audit what the server's doing. We should be able to audit what the client's doing. And so that's why Electrum's kind of cool, because the client and the server.
So it's also
read by even people.
Yeah, it's also important to know that that was I think the tail end of an era where people think that everything should be written in Python, like freaking freaking Dropbox was written in Python, I think, until they eventually abandoned it. So.
Yeah, that's true. There was a trend in like the mid 2010s, yeah, definitely for Python, and it's a great language, like in many ways, much more maintainable than other. Python was actually initially written to replace Perl, which I don't know if people remember Perl, but that was a nightmare. it's like a write-only language. You can't read other people's Perl ever.
Yeah, right. It's like the regular expression engine just generates limitless number of regular expressions, and that's your whole code base.
Yeah, and there was like 16 ways to do anything. There wasn't
right.
Like Python's all about the idiomatic way. Like they want the one canonical syntax for like X problem, Whereas with Perl, it's like 16 different syntaxes for the same thing.
So tell us what is Fulcrum or the Electrum protocol, and why is that stuff important?
So one way to do SPV wallets, Satoshi's initial vision for SPV wallets is that the wallets connect to the nodes, and they scan blocks and stuff, and they get Merkle proofs from the nodes. But that turned out to be more difficult to implement for various reasons. Like it's not, like if you want to figure out what all your transactions are in the past, like you got to go scan blocks from the beginning of time. So one optimization was just, all right, let's have like an indexing server in between that can like serve up requests, like tell me my balance, tell me what my history is. You have like a server in between that sort of does some chewing on the blockchain, and it can like answer like high level questions to wallets. And that's what an Electrum server does. Rather than having to scan the whole blockchain to figure out the answers to those questions yourself, you have this indexing server in between that can summarize the data you're looking for.
Listening, they might not understand, like, oh, so it's just an API, and now you're just trusting an API to tell you the truth. But is that the case? Right? I mean, I know that's not, but could you explain why it's not just an API where you ask a question and the server tells you the answer and you're like, well, I guess.
Right. So it has still SPV aspects to it. Like someone can't easily pretend. So that's like there are several ways that a server can lie to you. One of them is it can omit. It can say you don't have any money when you do. With the Fulcrum Electrum setup, that can still happen, right? Because you're still relying on it. Like you don't know what's out there. You're relying on it to tell you what's out there. But the stuff it does tell you about, you can verify is real, as that it has proof of work behind it, because you get an SPV proof for every transaction that it told you about. And there's proof of work behind that because you match to the header. So it can lie to you still. Like it is the best thing, I guess. The least lying would be you run a full node and you verify the chain from the beginning. That's the least amount of lying, right? And then less lying than that would be, you scan the blockchain using a peer-to-peer SPV node, but that takes forever. And I mean, there's more lying involved in that. But it's always about compromise, right? Like the most lying would be like, there's no SPV proof, right? You just ask the server, hey, what's my money? And it's like, hey, you have this money. And it can be totally lying to you to rip you off, right? To like convince you that you've been paid when you haven't been. And so Electrum's system is like one step before that. Like you can't be convinced you've been paid when you haven't been. So, but you still have to rely on the server. Yeah, you have to assume it's telling you the truth to some degree. They can omit funds. It can pretend you have no money when you do.
Right, so it can't lie to you directly, but it can lie by omission. Is that the right summary of it?
That's right. Yeah, that's a good way to say it. It can lie by omission, but it can't lie the other way. It can't like pretend you have money you don't, because you can always verify it against the blockchain. It gives you enough tools to verify yourself.
Right. And have you talked with Jonathan about this SPV library that he's making? Have you guys talked about that?
Yeah, we communicate. He often comes up with good ideas for API stuff he needs. And that's about the level of our interfacing, where I would be like, hey, would this call make sense for you? And he's like, yeah, do it that way. Because I've been extending the protocol a bit more features where like clients can ask more high level questions or whatever of the server.
All right, cool. And so that's the idea of what it does, right? Of what the Electrum protocol does or Fulcrum does. It gives you the information in an efficient way that's more useful. Like, for example, we run general protocols. We run our app, and we have lots of different things that need to talk to the chain. And just writing code to talk to a node directly is a huge hassle. And each node is different. So having this standardized protocol to be able to query and find out what's going on and get information is hugely valuable for application developers. So, and then you said earlier about Fulcrum, you decided that what was available was too slow, whatnot. So you decided to make the better version of it. Is that the extent of it? That you just wanted it to be, 100 times faster, or is there more to it?
Yeah, because a lot of stuff was on the horizon. Like we were going to do cache fusion, which involved like large transactions, and also we were still dreaming about scaling to the world, right? And this was like about 2019, and I was like, well, we can't handle that with the servers we have. We're going to have to throw away Electron cache because the server side just can't handle it. Because with cache fusion, you end up having really large histories, like because you end up fusing. So your wallet gets huge. You'll have like 30,000 addresses. You'll have like, 30,000 transactions. So like, hey, this is silly. You can't do this with the Python server. Like, it's just going to be too slow. And I was like, hey, I wonder how hard it would be to just write this in C++. And I did it initially as an experiment, just to see how much faster it could be. Like, just like, oh, if I just do it in C++, how much? And it was like a lot faster. And I kept going. I was like, oh, this is actually going to be useful because it's so much faster that people might be compelled to switch, just because of the user experience on it. Like, it's just like you click and your wallet opens and much faster. So
yeah.
Initially it was just an experiment. Like, I wonder how much faster it could be, and then it turned out to be worth it. So
first time I connected to one with so there's the Electron Cash wallet. Sorry. Yeah. The Electron. I'm getting all my names mixed up. There's the Electron Cash wallet, which has been like the absolute workhorse of the Bitcoin Cash ecosystem since the beginning. And the first time I connected it to a Fulcrum server, I can't remember whose was yours or you named somebody's, and I was just like, oh shit, this is so much faster, and it was so much more responsive, especially with a wallet that has cache fusion or something like that with a lot more things going on in it. I was sold immediately once I actually tried it. Speed is a superpower when you've got enough of it.
Yeah, I mean, it's like one of those things. It's like you feel like you're using quality software when it's fast. It's just like it's like butter. You
just
perceive
works.
It differently. It was an experience.
Right. Okay, so how about the other side of that story, the Electron Cash side of it? How did you get dragged into that? And what are your thoughts on Electron? Like where it is today and where it's going and.
So the lead maintainer really of Electron Cash was Neil Booth, really for like a couple of years until he went over to BSV. So basically it was like a war of attrition. Like he went over to BSV and then it was a vacuum. It's like who's gonna maintain this? But I initially got dragged into it. I did the iOS app for Electron Cash, and like that made me, and that's like almost its own separate app because it's like interfacing with the iOS stuff. This was before Qt could talk to iOS, so I had to write like a whole user interface, and so I got sort of suckered into that. And I didn't really know what I was doing. I didn't know Python, but luckily the iOS app used a lot of Objective-C iOS stuff, which I knew, so it relies on that more. So I sort of like Neil Booth was around, but I was doing my own thing in the iOS app. I didn't interface with him too much because he was a bit difficult to work with towards the end. I think he was upset about something, and so he left. And then like who's going to be the lead? Who's going to be maintaining this code base? And I sort of just, I got to maintain it now because like it is an important piece of the ecosystem, Electron Cash. So it happened by happenstance. It was mostly Jonald insisting that I work on Electron Cash.
That's a huge understatement. That it's an important part of the ecosystem, like a massive understatement, and it's a lot of work.
I don't know, is it still? It doesn't.
What's that?
Aren't there like better wallets coming, or really good like specific wallets coming out, like browser wallets? I've been kind of impressed by some of the browser wallets like that are just more user friendly. I mean, it is basically like a Swiss Army knife of a wallet, Electron Cash, but
oh man, it's an absolute workhorse. I mean, I've been using it for years.
Thank you.
By far, vast majority of the work I've done has been on Electron Cash. So, I mean, there are other wallets that are available, and they're good for each purpose. And Electron is good for its own purpose. But for me, and I think for a lot of people, Electron has been absolute lifesaver. And just the fact that it's so just solid, it just works. You don't have to worry about it. It just goes and it gets updated. Yeah, I mean, I use it. It's gets my wallet, maintained. So. and that's and to give credit, right? That's not only you. There's you. Who are the co-conspirators? So there's what should I call him? Axel or Ichundis? I don't know what name he wants to go by.
Yeah, Axel is I wish he'd participate more. He's really skilled. Axel Gembe.
He's great. Yeah.
He's really skilled. Like he's contributed a lot to the stuff that's like my weakness, like the build system and just other stuff, like random stuff. Like he'll contribute stuff that I suck at and make it good. So
nice.
Every single developer is myopic, just like Satoshi may have been on some things. I'm myopic on some things. So it's always good to have other quality people that can, help you see better.
I know Jonas helps out every once in a while. Who else is contributing to it occasionally?
There's also Donald.
Donald, yeah, of course, Donald. Yeah, that's right. Who else contributes to it regularly?
Jonas has contributed some good stuff too. Jonas has done some good stuff. He was in here earlier. I guess he got bored and left. But,
I tried to get him to come on stage, and he's like, "You don't want to just listen to angry me." And I was like, "Yeah, I do. We can just complain about things."
He's an angry. He's not angry, but he likes to art. He likes like counterpoint, which I appreciate actually. That he can bring up good points.
Yeah. I appreciate that we have a pretty thick skin in the ecosystem. You have to be in the black horse, the underdog ecosystem. So, all right. So there's Electron. It's very valuable. Massively appreciate your work on that. What about that? But where do you see that going? Like compared to where it is, and you were talking about there's other wallets available. Where do you see Electron Cash wallet going in the future? Do you have any thoughts on that?
I mean, I have immediate like bean counter piddly things that I could say. I don't have like a grand vision, like like Elon Musk. He wants X app to be like the WeChat of America, but I don't have that kind of vision for Electron Cash. I just want to say that up until this point, Electron Cash has covered the features more than other wallets. And it's not doing that as well as it used to. And I think I need to spend some time. Like one thing that it can't do cash tokens is like it can't do the NFT stuff and like the metadata stuff that other wallets can do now. And so just immediately, like the immediate need of Electron Cash is to cover that better, cover that feature set better.
See, I saw it the other way around. I mean, I guess there's some things that can't do in Cash Fusion, but when I picked it up, when you made your first implementation of it, I was like, okay, so you actually covered almost all the main bases of it, right? You can handle FTs, the fungible tokens. You can handle NFTs. You can handle multiple of them in a transaction. You can mix them. You can spend them with BCH. You can have an HD wallet. That's something the vast majority do not have with cash tokens. Is you can actually do regular HD stuff. You don't reuse addresses and that kind of thing as much as possible. So I don't know. I thought the opposite. I thought it was more complete than most right at the beginning.
Yeah, probably from day one it was, but it needs like it doesn't do BCMR fully, right? Like where you need to follow the auth head or whatever to figure out what the latest metadata is. And there's other stuff for like NFT specific metadata that it doesn't understand. So it's just small little things, I guess. But I mean, ideally, the vision for Electron Cash for me is like it should just cover like as many features as possible. Like it's like a power user wallet. Like I want to be a power user, and I want to sit there and I want to interact with the blockchain as a power user. So it should offer a little bit more with the cash tokens, I think.
Right. Okay. Did you ever touch the RPA, the reusable? What's the acronym you name?
Reusable payment.
Yeah.
What the A stands for.
Reusable payment address.
Payment address.
Yeah, reusable payment addresses. Did you ever do any of the work on that, or did Jonal do all of that?
He did all the client side, and then JT did the server side. He did it like a patch to Fulcrum.
Okay, all right. So that's kind of dead in the water right now, but I think it could pick that back up at some point if privacy became more of a focus.
Yeah, I think it probably needs to be resurrected. It certainly is an attractive thing to be able to have. I don't actually feel like it would be used that much, but maybe I'm wrong. You got to build it and figure it. Once you build it, then you figure it out.
Right. Okay. All right. Yeah, I remember when you were building the cash tokens part of Electron. Some of us were butting heads about what exactly needs to get implemented, and like I was pushing like the BCMR stuff is arbitrarily complex. You can't fully implement it because it has no full implementation. There's no such thing as handling an arbitrarily large and varied registry of information. You can't, there's no such thing as fully handling that. All you could do is, show it. But I really appreciate that you got all the actual like consensus level stuff was all in there. Like you could do all the things more or less that you need to do with cash tokens. And then the BCMR stuff, from my perspective, is like a layer on top of that, is like extra things that you can do with it. And they don't always apply, right? When you're actually doing smart contract ecosystem that's, providing you receipts and so forth, the BCMR stuff is more focused on like, meme tokens and stuff like that, which is less interesting to me. So I really appreciated that you got the nuts and bolts of it done right from the beginning.
Yeah, I mean, we spent all this time working on cash tokens. I wanted to be able to use it. So yeah, that was part of it.
Yeah.
Yeah.
And then I'm sure it will get the BCMR stuff too. Yeah.
Yeah, so we'll have it in there. Definitely, that's one of the goals.
Cool. Yeah, and I'd like to see all that stuff too. But anyway, I appreciate all that you've done with it. Then there's BCHN, right? Which you were there right from the beginning, helping to get that established and forked and built up and so forth. What have been your thoughts on BCHN? What have you learned?
Yeah, when you announced the stupid tax.
A stupid tax.
Oh, I've learned a lot. Yeah, I mean, I was about to sell my whole stash of BCH and walk away when he announced that. And then like JT was like, hey, we're gonna fork it. We're gonna fork it. And he was the optimist. He was like, we're gonna do it, man. We got the skills, we got the tools, we got the talent. We're gonna get the community. Like, we'll get the ticker. I was like, oh man, I was so defeated.
You're like, I've seen this story before. I know how this goes.
Yeah, I was like, oh, he's gonna get the stupid ticker, just like BTC got their dumb ticker, and then like, it's gonna, that's it. It's over. I'm not participating in this.
Yeah. And I think a lot of us were right there on the edge.
It turned out to not work out that way. So it was like a competition. The first year, like BCH had to be more compelling to some degree, in some way, or at least compelling enough that miners would go with us, right? So, I stuck around. I tried to make it as fast as possible. Like I improved a little bit of, like I saw that there was some on the JSON RPC stuff. It was a bit slower than it could be. And so some of the miners were like, hey, this is faster. Okay, we'll install it. And we don't want to pay 10% tax anyway, so it's an easy sell for them.
that was a particularly interesting period of in history, I think, because that was the time when I realized like there was a lot of big talks about like how we're gonna do radical changes to the protocol and the software in order to get like really good performance, right? Like in order to scale. Holy shit! Like so, on the ABC side, there was a lot of proposed protocol changes, and people, and then there's BSV side, which is like, oh, we are gonna write this Terra node thing from scratch. Did they ever deliver on that? I don't remember.
Meanwhile, they couldn't even get they couldn't get the engine from chain thing fixed, like the mempool thing. Like they're talking about these things that are like putting the cart before the horse. Like get the basics.
Yeah, and then during that period, I was like, wow. There is a lot of performance to be had, and there's to be had just by like getting down to earth and improving the code like here and there at a time, and then you get 20% here, you get 10% there, and then it adds up a lot. Damn, what and those people after all those years, what did they deliver? I don't know.
They ended up backporting the fastest thing that I think done was getting the mempool to be fast, like not having that n-squared problem where you can have 40,000 transactions.
Right. That was a big silent upgrade. I think most people don't realize what happened there, right? With the chaining. I think people don't understand. Yeah, those things are kind of invisible. Could you describe that for us real quickly? That specific problem that was solved for chaining and the reduction of the time complexity of that part.
Right. So the way core, so initially the mempool was not like this. Well, initially the mempool was almost non-existent, but at some point the mempool of Bitcoin was you just add a transaction, and then that's it. There isn't any consulting of other transactions. It's like in an n-squared fashion. But what ended up happening is like Core decided their strategy would be like to optimize for fees. I guess they were already planning on having like a congested network. So they started adding changes where transactions get bundled together with the ones they're related to. Like if you're a child transaction, you sort of update your parent and you update your grandparent and your great-grandparent and your great-great-grandparent. And sort of all the transactions are aware of each other. Like they come as a package, like a fee package. And this is like, this is a design trade-off because, either you're gonna have high capacity or not. And like that design is an n-squared design. Like every transaction you add has to like talk to all its parents, like, and they may have multiple parents and multiple grandparents, and like it quickly branches out. So that doesn't scale. Like, so initially Core had like 25, you couldn't have a transaction that had more than 25 like total ancestors because it has to talk to all of them. And then like, and that gets really slow. Like just adding a new transaction ends up being like, it takes 100, like it'll take like 100 microseconds and a millisecond and 10 milliseconds. And, it scales like quadratically. And so that was in there. And then that was a problem for BCH for a long time. Like Roger Ver, like you would end up hitting that wall because if you're doing something like Read.Cash or Bitcoin.com wallet, your users are sending transactions, and at some point it just says no, sorry, I can't accept another transaction. It's got more than 25 ancestors. And so that was a problem for like years, for like since 2017 or 2018. People were trying to like pressure ABC. They're like, hey, can you lift this limit? Can you make it unlimited? Can you or at least lift it? We're hitting this wall. Like 25 isn't that much. And so, yeah, ABC like just like sort of stalled it, and then they added it. They made limit 50 ancestors, but without having improved the code at all. They assumed, just because the hardware got
better. So, yeah, there were real world issues with this, right? Like Satoshi Dice, which is all on chain, they're just straight up hitting that limit and having to write all kinds of software to optimize, like running multiple parallel chains of transactions to get around that. So it's just a pain in the ass to write that kind of software, and it's easy to fuck it up too.
Yeah, it makes integrating to the blockchain just harder. Like you have to manage your UTXOs, and then this UTXO has too many ancestors already. I'm going to retire it for a little while until they get confirmed, and then I'm going to take these UTXOs out. And it just gets it's like a nightmare for a developer.
And then even not just for the developer, but like you said, for the node itself, it doesn't scale. Even if you do allow only 25 or something like that, at scale, if you had a large number of things like that allow 25, then it becomes extremely inefficient, right? Which is the killer for scaling. And I mean, complex, the time complexity will kill you on scaling.
Yeah, let's put it that way. So we got rid of that. Basically, we don't optimize the fee packages. Like before you had child pay for parent, now you can have like child punish for parent. Basically, we just like start confirming, when we're building blocks for mining, we just like start with the parents. And then like, if the parent didn't make it in because he was stingy, but the child paid a lot of money, they're not going to make it in together. Because we don't keep track, we don't do the crosstalk between the two transactions that together they add up for a lot. But like the parent was really stingy, but the child was generous. We don't, for fees, I'm talking about for fees. We don't do that. We just mine in a, in a more simplistic fashion, but it's very performant. Like you can build like a 400,000 transaction block really quickly. Like you don't have to do all this crosstalk calculation insanity.
Yeah, the value of simplicity, right? Keeping things simple.
And so we took out the fee package stuff. No one noticed because we're not like a fee congested architecture right now. No one noticed. People just noticed that the mempool is faster and that you can have unlimited chains now. So that's all they noticed.
Yeah. And well, no, some people definitely notice, right? The people like Satoshi Dice and others who are writing apps that might run into those limits. They absolutely notice, and they had a breath of fresh air that they didn't have to not only code for it, but then sometimes hit that limit and have to deal with the fallout of, I thought something worked or was going to work and it didn't, and now my state is corrupt and whatnot. Not the blockchain, but their app state got, just becomes complex. So no, definitely.
It's just a nightmare. Yeah, definitely. I mean, people were very happy when that limit was lifted. Like the people that write, like the Read.Cash guy, he was happy.
Right. Yeah. They were.
A lot of various.
So how about other things at BCHN? What have you learned there, or what have been the most interesting parts that you've worked on? Because I think you've touched almost every upgrade, major upgrade, and the minor stuff on consensus, as well as just the node details and operations. What are the interesting things that you've noticed or worked on?
Oh wow, that's
like, which of the upgrades was the most fun and the biggest pain in the ass? Like, how about those two?
The most fun was the cache tokens.
Really?
And before that, the introspective opcode. That was the most fun because it was well specified from the outside. Like Jason Dresheiner thought about all the difficult things, like the difficult questions about what the opcode should do. It was well specified.
I was part of that process. That was the most epic upgrade process I've ever seen, like anywhere.
Why? What was epic about it? Say more.
Epic.
Like it was just epic, like the depth of discussions and all the things that were considered and written out extensively. Yeah. That
was like the whole evolution, right? Like from the early versions of it, like group and PMV3 and Mitra and these various ideas, and you're talking about like that whole evolutionary process, or especially
not just that, but the cache token chip itself, I originally proposed the chip process, but I feel like, through cache tokens, it was like, wow, like this, holy shit, like this is the bar this is the bar from now on. Like, right. I don't know how else anyone else is gonna do it. Like that's a bar. Like we were gonna have to live with this from now on.
The bar being way up here, which is excellent. That's exactly how it's supposed to be. I see.
Yeah, it was a tremendous success. Like you had someone who isn't on the dev team but is technically knowledgeable. People like that sort of thinking about the problem and then talking to the devs, and the devs being angry at first because you're going to make all this work. Let's make it simpler. Can we do this? Can we do that? It was really healthy. It was like a healthy debate, and the whole thing was really successful. The chip process, like really, it's amazing.
And in contrast to pre-chip process, right, where it was basically kissing the ring of the lead maintainer of ABC was the way to get things done. It was just so much more collaborative, and not rushed was huge. I think just not being rushed, like, we gotta get it done by a certain. It was more like, okay, look, it's not ready. That made a huge difference. I think that it wasn't rushed, and it wasn't just some arbitrary hard deadline that things had to be done by. If it wasn't going to make this deadline, then we'll do it on the next one. I don't know. Did you feel that too, that it wasn't rushed and constrained? And
I mean, it felt really well thought out. By the time I opened the spec up, a lot of it was well thought out. I think we had it done before, like in October, like before the November 15th, which is sort of the soft deadline for us, or even earlier than that, maybe September it was done.
Yeah.
This was it was very ambitious, a lot of changes to the code, and the most like on time or early, and the most well thought out. And that came from the experience from the previous chip, which was the native introspection, which also ended up being it was like an orderly process. So I don't know. Yeah, it was like the most fun to work on. That native introspection was fun, and the cache tokens was fun.
Yeah,
because it was just well thought out. Like we knew. I don't know. Orderly process, no stress. Like
well, that's what I was saying. I think the reason they were well thought out is because the whole process made it so that it was collaborative, and I think everybody started to get the feeling
that way ahead of time.
If it doesn't make sense, everything happening ahead of time, and if it doesn't make sense, it's not going to go through. There's no amount of yelling and screaming and asserting things that would convince people, because as soon as you did that, people just walk away. It's like, yeah, no, not doing that. So it just lends itself to people needing to cooperate, being incentivized to cooperate. So, and then there was also people like Bitcoin Cash Artist who made an absolutely huge difference in just keeping the ego out of the picture and letting things move ahead and different ideas take the stage, get judged, get included or get pushed off. He did a pretty epic job there too.
Yeah, I think I mean, we probably mentioned it like multiple times, but cash tokens wasn't the only proposal. Like, okay, this is what we're gonna do from now, and that's it. Cash tokens had a serious competitor in Bitcoin Cash Alta's modern group, and it was basically follow up all the way, and it was a fairly competitive process, and we ended up with cash tokens. But I think it shouldn't be forgotten.
Yeah, he herded the whole thing, shepherded the whole thing from the group version to PMV3, and then later to cash tokens. He was there for the whole process.
Yeah, and I think we ended up with like a technically, like the least amount of technical debt, like just the cleanest implementation for what it is. Like, it was just like, well, it got lean and mean, because it went through the process of competing with an alternate thing, and it took out the good stuff from the alternate. And it was very like an evolutionary process.
And it involved people with different skills, like you said, who are myopic but skilled in one thing or a few things, and others who have other skills. And like Jason, he has an amazing approach to everything, and he understands things very well. And I think of him kind of as an artist, right? Like, I think he sees himself a little bit that way, where he told me one time, he didn't design cash tokens. Cash tokens is what emerges from the properties of Bitcoin, is the way he described it. It's kind of like the way, I don't know which artist it is, but the sculptors, they don't hack away at the rock to make a sculpture. The rock tells them what's there, and they just reveal it. So he talked about cash tokens that way. But then he's not a high performance node developer either. He's not a node developer, so he doesn't have all the insights that he needs. So I don't know. Yeah, a lot of different people came together to make it great, like you said.
Yeah, for sure, man. He loves Bitcoin. I can tell you that. He's got good sensibilities. Definitely a good guy to work with.
Let's. I do have something that I want to ask about, like in interactive setup, like because we were talking about performance and robustness at the time, right? Something that I have wondered for a long time, and because I'm not a real dev, it's probably really useful to get insight for both myself and other people, which is that I look at things that are robust, like Fulcrum and the modern Electron cache. I mean, there's a lot of things to be improved about Electron cache. Sometimes you still have like annoying bugs here and there, but it's generally pretty robust. And then I look at them, and then because I've been around for a while, I remember there were some really I don't want to use harsh words, but there were some really non-robust things that that were critical to Bitcoin Cash in its history. And I want to just throw two things out. I want to just say like the two things that immediately came to mind, and because they directly contrast Electron Cash and Fulcrum in their robustness. One of them is Badger Wallet. Like, you guys remember Badger Wallet? Like, holy shit! Like that.
We don't talk about Badger Wallet.
Badger Wallet. And that thing just like it crashes. It gives no feedback. Like you guys know what I'm talking about. There's Badger Wallet, and on the server side there's SLPDB. Like, numerous people tried to fix it, and then it failed, and then they tried again, and then it failed, and then it tried again, and then eventually people just give up on it. Okay, like it's probably not going very far. I know like Chris Troutner still maintains a modern version, but he basically and he probably made some improvements a bit to it, but he ended up just like throwing out the big, blacklisting the big tokens and then call it a day. like one thing I want to know, like in concrete terms, is that what kind of practices led to the difference between like robust and non-robust software in terms of what we experience? Like what do you think, like in general? Like is it just a skill issue, like or is there some general rules?
Just be paranoid as a developer. Be paranoid as a developer. Be like, you're an idiot. What do you think is going to work may not work. Like, figure out a way to break your own code. Figure out, how are your assumptions going to fail? Like, when you're developing, you should always ask yourself that, I guess. Like, be your own worst critic. And be, experience like it. I don't know. I don't really know. I think the developers that worked on all those things that you mentioned didn't have their heart in it for some reason, or didn't have experience. With SLPDB, I think that was James. I think he just didn't like it. He didn't have the experience. I think and with the other stuff like Badger, I think wasn't that just like Bitcoin.com hired a bunch of devs that didn't care, and sort of they did a smoke and mirrors job. Hey, it's not, wasn't it something like that? Like, the requirements are met. Here, here's your product. Here, give us the money. Bye. Wasn't it something like that?
I mean, from the interface, it's more like it's more. I think it's mostly like, okay, we got MetaMask, and we will hack it to work on BCH in the shortest amount of time possible. I think that was what happened. I'm not sure if that was.
Yeah, I think it was more of like a ship it type thing. Like, you got to get it out there and get it in people's hands kind of approach. Yeah, and that was built on top of not Bitbox, but was it Bitbox. Anyway, it was built on a very shaky ground as well. So yeah, it didn't have a whole lot of hope for the future given where it started. But yeah, actually, paranoid programming. That sounds like great. That's what I used to always get criticized for in my last job was paranoid programming. I was like, oh, that's what I do. It's called paranoid programming. They're like, that's bad. And I'm like, I don't know. That's what I do.
Yeah, and a lot of that just comes with experience. Like, you just you make all the mistakes early, and then hopefully you don't make them again. But there's like entire books written about this, how to engineer software in a robust way, and no one's figured it out. I mean, you could do your PhD thesis on this, and even the stuff you come up with. There are probably things you can do to make it better. There are processes. And I don't know.
And really, the whole coding stuff is such a young industry as a whole, right? Like, it's orders of magnitude younger than other engineering professions. So yeah, there's certainly still a lot of room for the whole thing to grow and have standards.
I mean, the way it works is like software is so complicated. Like, it can be complicated. You want to reduce the complexity as much as possible. But I mean, like, really, like having high quality devs that really know their stuff. Like, that's the key. And then, like, a lot of places don't. There's only going to be like 0.01% of the population, whatever, that's like amazing at their job. And I don't know, like, that's part of it. Like, being wary of who you hire to work on something.
Right. The best devs take Bitcoin Cash, so load up so that you can afford them. So we're going to run out of time, but before we do, was there anything you wanted to say about the pool software that you did? Or that you still maintain, or the CP miner, or anything like that? Is there any insights you've gained from working on that? I know, like, when I see you, a mining issue comes up, and it's just the nature of the way things are that vast majority of people don't have any experience with real mining. Like an actual mining operation, or even most with mining itself. So, what did you learn from that has been useful?
Like, a lot of the devs that work in the space, like, don't even know how to run a miner. Like, they haven't owned a miner. That really happens, man. Like, I would be surprised if any of the ABC team ever like set up an S9 and that just gives you insights into the mining world and what miners think about and how the mining software works. And like, I don't know, like, it was a good experience having to maintain that software and then, like, throw an S9 on it and see what happens. And learning how that whole world operates. I mean, in the Bitcoin core world, I think Luke Jr. is the only one who knows mining really. Whenever there's a mining thing, they ordered him. So I think as a dev, like, mining if you're going to be writing node software, like, then you should at least like know how the mining stuff works.
Right.
I don't know. And so being forced to maintain that pool, the CK pool / A6 tier pool, same software, being forced to maintain that or being asked to maintain it really gave me a lot of insight. And I think that it was a good experience in that regard.
I know people will come in with like good ideas in quotes, right? They're like, oh, we should just do this thing where we do the Coinbase transaction happens like this, or you add an op return here, and you're like, oh, no, that doesn't work. That's not how miners work. That's not how the pool software works. And all you're going to do is make everybody angry with us. So it's very easy to miss those practical issues like that, where you won't be able to, or something that sounds right on paper actually isn't going to fly in reality. I've seen that come from you several times, where you point out stuff that it's not going to fit. Did that most of that come from the work you did on the pool software, or did you just get that?
Yeah, for sure. Yeah, for sure. Working on the pool software, and then like having miner friends that were telling me, how they like to see things and how things work. Yeah, 100%. So, I mean, yeah, but sometimes my assumptions are wrong. Like, it always pays to just ask a miner, really. But sometimes you can have some insight ahead of time. I think whenever you're going to change the Coinbase or something, just talk to the miners, like always.
Yeah, absolutely. Yeah. Okay, I have one more question that I really wanted to ask, because I've heard you talk a little bit about it, and I think it might surprise some people. So I'd like to get a record of it that people can listen to. So the most famous case of what I want to ask about is like the block size limit, right? Where people said, look, it's so easy. You just change one number, and then, it's going to change everything if you just change this one number. And of course, abstractly, that was totally true. And even technically, to some degree, that was totally true in that specific point. But when is it the case that, something that looks easy, that sounds simple, for someone who's not an engineer or not a full node engineer, what's something that sounds simple when they're just like, just change this one number, just change this one thing, and it's going to make, everything better. It's going to make the economics work better, or something. But then that's not actually the case. Have you seen any others in any things like that, where something that sounds simple from the outside is in reality not simple or not straightforward?
Not specific to block size, just in general, or
block size was that the case with block size, right? Because that was definitely the narrative. I'll just change this one number and everything will be better. Was that the case? Like, for example, if I take that to the extreme, and there's some people who are like, just completely remove the block size. And I think we established with the recent adaptive block size algorithm, I think it's pretty well established, right? Like, removing the limit creates its own set of very serious problems, like existential issues that are very dangerous. So that's not a good engineering idea, even though it sounds good, like economically, like, oh, let the market decide. So that kind of thing sounds good, but then, that's actually a bad idea. So yeah, with block size, but even at a lower level, like just increasing from 1 megabyte to 8 megabytes, was that really straightforward and an easy thing to do?
That was reasonably straightforward, because what Core was doing was they were artificially constraining the software,
of course,
to something ridiculous.
Right.
So, from 1 to 8 was fine. The thing is, with every engineering change like that, like, there's a cost to blocks, right? I mean, they take up this space, they take time to transfer, they take time to evaluate, to propagate. So, if you go to as block size tends towards infinity, you're going to have like a non-functioning blockchain on modern hardware, modern networks. Like that, that's true, right? So, you have to find the sweet spot, right? Where is it? Is it at 1 megabyte? Is it at 32 megabytes? Is it a gigabyte? You can explore that, and then you run tests and figure out, it's like anything. Like, you want to build a rocket, you can't put like an infinitely large engine on it. At some point, you're just going to burn up in the atmosphere, because you accelerate at 10 kilometers per second in 1 second.
And it's still not going to go that fast.
Like 1,000 Gs, I mean, maybe you'll have like a fireball, like you'll have just the engine that's left, the engine nozzle going into space, but the rest of the rocket will burn, right? So there's always constraints in engineering, right? So you have to explore those, and you have to what happened with Core was completely just a psyop. Like, that was just a lie.
Yeah.
And then, what happened with B is they went nuts because they had to differentiate themselves and that, be rebels. So they ended up doing the Gigablock, Gigamegs, which, wasn't well engineered. And so they have problems now.
No.
But,
yeah.
We have a history of like Core having stuck to basically hobbling the chain. So it can't be adopted. Like Bitcoin went from positive adoption to negative. Like, you don't see anybody accepting Bitcoin really. Not in any meaningful way. Like not the trajectory is altered completely, right? So, they had their agenda, and so they're making up smoke and mirrors arguments about block size.
For sure.
Which was like, oh, it's got to be really tiny, basically. And, that wasn't true. Like, there's engineering ways to go about this. Like, and it depends on what you want the properties of your network to be. I mean, it seems like someone wanted Bitcoin to be constrained, and then it seems like that was rewarded with like a lot of investment or something, or a lot of money, money.
Yeah, what was it? 50 million? 10 or 50 million? Something ridiculous. Yeah.
Initially, Blockstream was like 70 million, I think. And then they hired the devs. But then after that, you have to wonder, like maybe some of the bankers that paid Blockstream, now they were happy. Bitcoin is hobbled. Let's like pump money into it so it stays at #1. So like the flagship crypto, everyone thinks crypto sucks. Like, I don't know. Like, it depends on what you want to achieve. So with Bitcoin Cash, we want to achieve it where it's used for money. It's money. Like mom and pop. You could pay for your coffee. You could buy a T-shirt. You could order stuff online. You could. That's the whole. That's the whole philosophy of it. Like, so let's engineer the block size to be reasonable. Like you want people running nodes. You want it to be decentralized. You don't want like an attack vector to open up. So like if we had like infinite blocks tomorrow, like you could see somebody like spamming transactions, like annoying everybody. It would probably cost them like a few $1,000s, like every block or whatever to do that. But
or even, I mean, in the worst case, like lock up the chain, right? Where software stops being able to process it and everything just chokes. So yeah.
I mean, that's one thing.
Okay.
So everything comes with a cost, this is what engineering is like. But the core people weren't doing any of that because they were already like, they had a conflict of interest. Like they knew what their roadmap was.
Exactly. Yeah.
So they were just like making up smoke and mirrors arguments. And then BSV was like using their large block size to make fun of Bitcoin Cash. But their chain is like impractical. Like, try running a node, see what happens.
Yeah, and I mean, even if you take BSV at its absolute best interpretation, which is really hard, but if you try to take it at its best interpretation, it's like an economic argument, right? Like, oh, just let the market decide. And it's like, well, how about we be practical and think about all of the angles, the economics, the engineering, the finance, all of them, the security, the robustness. Anyway, that's what I love about Bitcoin Cash. It's the practical Bitcoin. We actually look at all the angles and consider the big picture. So, but back to the question is there anything that people might think, oh, there's this thing that's important and it's easy to do, but then when you actually look at what it takes to accomplish it, it's really not easy to do and it's not straightforward. Have you heard anything like that? And maybe there's not such a thing, but have you heard anything like that where people wanted something and you're just like, no, trust me, that's a bad idea?
I probably have, but I can't think of on the spot.
I can join in here.
Something.
Okay.
Right. Loops. Right.
Right. Yeah. Let's put loops into it.
Oh, in the scripting language.
Yeah. Sounds trivial at first sight. Why not just have some loops in there?
Yeah. Right. Then you have that whole problem. Well, then you got to come up with a whole system.
Yeah, there's like also the general class of things where if we do this, it forces us to revalidate a transaction after it's been accepted to the mempool changes. There's some in there that seems trivial at first sight, but once you look at it, like they destroy the entire architecture.
Yeah, like a non-local state kind of thing, or can you think of a specific thing?
So one example that I know of is people say, oh, why don't you allow your script to know what block the transaction is in or what block a transaction was in? And it's like, no, you really don't want to do that. Like that breaks the locality of information and it creates a dynamic piece of mutable data that can come into your system and has to be reevaluated. So that's one example where it's very dangerous to do something that sounds simple, or checking timestamps on your transaction. There's some things you can do that sound easy, but then it's like, oh no, that means you need to evaluate your whole mempool every time a new transaction comes in, or every time a block appears, that kind of stuff. I don't know, in any of those.
Yeah. On the surface, something like
just
time.
looking for insights.
Bitcoin has trouble with time, right? Bitcoin has trouble with the notion of time, right? And so, yeah, just something. Oh, you just check a timestamp. Well, give me the timestamp. Put it, OP timestamp. What's wrong with you?
Yeah, OP time. Yeah, very dangerous thing to put in there, right? Okay, all right. Well, anyway, that's any insights you have there, I'm sure would be very valuable. Maybe we can talk another time. So I think we should probably wrap up. We've gone way over our normal time limit, but just there's a lot to talk about, and I really appreciate you taking time to come and talk with us and share for everybody, right? We record this and put it back up so that anybody can hear this in the future. Is there anything you wanted to cover before we wrap up?
Let me think. No, I mean, the only thing I can say is it's probably a little bit off topic, but I've been sort of paying attention to the ordinal stuff in BTC.
Yeah.
And there's like a second wave now of like rebellion fomenting in their, they're pretty upset. I don't know if people in the audience are aware of what's going on over there, but it's one of the BTC guys came to me and he's like, hey, can you fork, can you make a fork of BTC that like filters out these transactions? I was like, oh, sure. But then I don't really know how Taproot works. So I had to look at the spec and I had to look at how it works. And I was like shocked. Like they got rid of like, basically they made it so you can put data in there really easily. They got rid of like any of the limits. It's like 10, you can have 10 kilobyte chunks in the transaction. The transaction can be 4 megabytes. It's like insane, right? And so I was like left to wonder, like, and then I went back to the discussions of Bitcoin, of like how they, how this change made it in. Like no one raised the issue of like data carrier. Like, you're making the transactions to easily carry data now at a discount. It's like 75% discount.
Yeah, it's so stupid.
Per byte. And I have nothing. Like no one had raised any point. It was basically like the two of the gods of Bitcoin Core were SEPA, Peter Willie and Greg Maxwell were into this thing, and everyone else was like, oh yeah, this is great. And they would do piddly things like look at his code and be like, oh, you want to move that parentheses there, but they didn't. No one like really asked like the big questions about it. Like it was so strange. And I went because they have all their IRC chat logs. You can go and like you can see all the discussions. They're all recorded. And it just felt like, these guys need a chip process, or they need the devs to lay off and like let outsiders propose things, or they need to do something. Because I'm not sure if this was like designed by committee where you become really myopic, like you're in an echo chamber and you become myopic and you make huge mistakes, or if this was sabotage, like one of the devs was paid to like, hey, let's figure out a way to get like data on the blockchain so that we can really constrain things and then miners make more money. Because right now the miners, like for some blocks, they're making more money they're making more money on fees than on this block subsidy. So I don't know. It's a case study in what can go wrong in a blockchain with the ordinal stuff. It's really interesting to observe, and I think we at BCH don't have this problem. Like the devs are not. We're pretty laid back. We're not trying to like stifle anything. There's a chip process. They're mostly dominated by people that aren't on the dev team. It's not an echo chamber like that. We're a band of rebels, and we sort of are getting a little bit more professional now about things we're doing. So I don't know. It's if you follow the ordinal stuff and you dig deeply, like it's just like so fascinating how that happened. Like how is TapScript so broken?
Fascinating, like a train wreck.
The devs now don't really want to fix it. It's like a train wreck, and you want to explain it. Like the tempting thing is to say, well, these guys aren't dumb. Like they knew what they were doing. As a node dev, I'm tasked. Like this is one of the things I have to guard the blockchain against like data carrier, because we don't want data carrier on Bitcoin Cash. We want to use this money. That's what we want. If you want a data carrier chain, there are other chains that do that. So I'm like tasked, like I can't believe they didn't see this, like that this would just be used as a data carrier. So either they're just in their own echo chamber so deeply that they just don't know what's going on anymore, like because no one says no to them, or like someone paid them off. Like it's one of the two. I don't know.
It's one of those things, right?
It's a little bit off topic.
With Hanlon's razor, you generally you don't start out assuming people are malicious unless, you know, like some kind of lethal force is involved and you don't have the luxury of making kind assumptions first. But generally, right, like Hanlon's razor, you assume people aren't being malicious. But man, especially when smart people are involved and capable people like those guys are, at some point you get to the point where you're like, this doesn't make any sense at all. And the simplest explanation starts to be malice, right? Like there's an agenda somewhere, because otherwise it doesn't make sense.
Or like subconsciously. Yeah, and people can do that subconsciously. Like their incentives could be implicit in their subconscious mind where they just don't want to see the forest for the trees anymore.
It's possible. Like, yeah, I don't know.
I don't know. I mean, we saw that with COVID, right? We saw smart people like just not say anything. I mean, you can see patterns of, you know, it's just really interesting. It's like a case study in how things can go wrong.
Yeah. BTC is a case study in how things can go wrong. That's absolutely true. Watching the train wreck on.
That's the way I see it.
Yeah, but man, it's so painful, right? Like you said, the reverse adoption. Like there's that graph of transactions, and you watch it just climb, and it's obviously an exponential curve. It's like, right, it's building up. It's starting to, I mean, it's like any exponential curve. At any point on the curve, it looks like an exponential curve. So it's just amazing. It's starting to go up, and then it hits 1 megabyte and it rings like a fucking bell, right? It hits that 1 megabyte limit at you know, around like 2000, what was it, 15, 16?
2016 maybe?
Yeah, 16. Yeah, maybe it started to hit that limit, and it just literally like rings. It's like ping, and you see that those transactions just oscillate and then just start to fall off as you know, as it just bleeds users and use cases, and people just go elsewhere and do other things. They go off to Ethereum, they go off to make their own chains. Bitcoin Cash is forced to fork off. Man, what an absolute ringing of the bell that was, and so much time has been lost since then. So yeah, it's an experiment, and you watch it and you observe it and you learn something from it, but it's also a fucking tragedy. And we got to make sure not to let that happen again.
The most ridiculous part about that is that it was like 2013, 2014, where people like predicted this would happen. And then in 2015, like the lead dev of the project, Gavin, made strong words saying that we need to fix this now. We still have time to do it, but if we don't do it now, shit are gonna hit the fan. And I still remember seeing like the presentation by Peter Risen when he went to BitPay and explained all this well ahead of time, also around 2015, 2016 sometime. And despite all these very, very clear pointers and so many people being able to give accurate predictions of what was going to happen, it was still met with, we can't even do 2 megabyte. Not even after we agreed to do it by word. We have to weasel our way out of it after the Segwit 2x fork, just not to have that 2nd megabyte. And the end result they get is, hey, 3/4 of our chain is now filled with spam, like these ordinals, and they're discounted.
And the discount, yeah, man.
Yeah, they get a 75% discount. Yeah,
trash tier engineering.
Yeah, that is the most absurd part that I find. That okay, so I guess we can do it on. I guess ordinals is okay in some way, even though it's not very pleasant. At least they pay the fees, right? No, they pay less fees. They pay less fees. They pay less fees than your, you know, than your non-important financial transactions. Like they literally pay less to store like doc pictures and other JPEGs. Like holy shit, man.
I can see this like the silver lining to this dark cloud, and if I may, we can assume that there are like powerful interests that worked to capture Bitcoin, and you know they got their captured coin, and they're leaving us alone. So that's good, because you know we can just like stay in the shadows or stay. You know, we're like number 20 or whatever, number 19, 18, sometimes we're 10. You know, maybe this is good for now. Like the actual free Bitcoin that closer to what Satoshi had in mind is alive and happy, you know, and it's filled with smart people who aren't just there for the maybe it's a blessing in disguise, like Jesus said, the blessed are the meek. We're a little bit meeker now, but there's less to distract us. We're not a target. They got their captured coin. They can manipulate it all they want. They can throw money at it. The bankers are happy. The CIA is happy. I don't know who's involved in this capture. I have no idea, but I can only guess because there's a bunch of actors that are involved in everything. Bankers and CIA. But I don't know. So for now, it's a blessing. Like it's a silver lining, and maybe the time will come when people will have had enough of the traditional system, so much so that it'll be too late.
We actually have
Bitcoin Cash.
Yeah, we actually have one more thing in our favor, and it's the fact that for every passing day that technology moves us forward, the decision to stay on 1 megabyte becomes ever so slightly more ridiculous, and our position to sensibly scale and be a practical version of Bitcoin becomes ever so slightly more vindicated as a valid choice. So yeah, I think we're doing the right thing here.
And there's also another one is on the same topic is if we hadn't seen that and just looked at it and said, oh my God, this at the very best is like gross negligence. At the very best, this is gross negligence in engineering, which can even be a crime, like in some places, in some situations. But, and at worst, it can be much worse than gross negligence. But if we hadn't actually lived through it, then we probably wouldn't have come up with the chip process, right? That we wouldn't have had the motivation to say, wow, we really have to understand the social layer. You can't just think of this as a piece of software. It's not that simple, right? This is money, it's economics, it's social, it's political. There's all kinds of angles to it, and we have to handle all of those. We can't just treat it as a piece of software. We wouldn't have had the incentive to really internalize that. So I don't know, as Jeremy from Bitcoin Cash podcast, he says, there's no other way we could have gotten here but the way we got here. And of course that's a tautology in some sense, but like if things had gone differently, maybe we'd be in a worse situation than we are. So whatever it is, we are where we are, and we're definitely making the best of it. And we have a pretty impressive ecosystem, and I think it's just going to keep getting better. So, Calin, thank you for everything that you do in Bitcoin Cash, for making everything better, robust, for being a paranoid programmer, and making me feel better about being a paranoid programmer. Thank you for all that. And
well, thank you for having me. I'm humbled by everybody that's involved now in Bitcoin Cash. I'm really happy with everybody. Like, thank you. I'm humbled and I'm honored, and thanks for inviting me.
Yeah, I know. Thanks for sharing your thoughts, and I think it's going to be very interesting for people to hear stuff they may not have heard about the deep programming and opinions about Satoshi and all that stuff. I think it's all going to be very interesting stuff. So, thank you for sharing it with us.
My pleasure. My pleasure.
And with that, I think we will wrap up. So thanks again for your time. Thanks, Jonathan. Sorry for the issues with Twitter. I have no idea. I tried.
It's Elon's fault.
It's Elon's fault. Yeah. That's the go-to. Just blame it on Elon. All right. Thank you, guys. It's good to talk with you. Have a good week, and we'll talk with you again next week.
Bye.
Bye.